Hello everyone. Today we're going to discuss how we can use the same clock signal to facilitate a sequential circuit which will have some part of it activated at some clock cycles and some other part of it will be activated in some other clock cycles. What do I mean by that? We know in x86 or y86 processor there are different stages. For example, we have fetch stage, decode stage, memory stage, execute stage and all the other stages, and these stages require different number of clock cycles. For example, in y86 processor, the fetch stage requires 10 clock cycles. The decode stage requires 1 or 2 clock cycles depending on the implementation, and the memory clock cycle is 8 depending on how we have implemented it. So overall, if we have a processor that we will just have these 3 stages, it will require 10 plus 2 plus 8, that's 20 clock cycles. So here we have a counter which can count up from 0 until 20 and then we'll wrap it around, and by using this counter we can actually design a circuit which will be activated only at some part of it. For example, in this circuit we have a counter which can be found in the Logisim library under the memory component counter, and this counter will have different ports that we have to set accordingly. For example, to count we need to set the M2 as 0. We need to set the M1 as 0 and M2 as 1. We have to set also the up counter as 1 and the down counters to be 0. And also we have to set the G5, which is the enable pin, as 1. We will be supplying our clock signal at this pin, which is 235 C6 pin. And by using this, we will be counting from 0 to 20, so which is hexadecimal 14. If we just enable this counter, we'll be able to see that it counts from 0 to 20 and then wraps it back from start again from 0. We also have different marks which will get like 3 marks for these 3 stages that we are going to simulate here. For the first stage we have 1 marks, for decode another, and for memory we have another, and we have 3 outputs, F out, D out and M out, accordingly showing the output of these stages at different time. What do we have inside these stages? For simulation purpose, we don't have anything other than just a counter inside these stages. So every stage, for example, fetch has a counter which has only one input clock and another output called fetch out. So this is just to show that this works. It doesn't have anything with the actual fetch stage of the processor, but it takes some cycles to do this counting, which is said to be 10 or hexadecimal A. Similarly, the memory stage also has a counter which has a memory out pin and a clock input pin, and the maximum value for this wraparound counter would be 8. So similarly we have other stages like decode. So if we go back to main and try to simulate this using an auto clock signal that will generate from 0 to 14 and then come back, we should be able to see that fetch counter counts from 0 to 10, and at that time the decode should have all zeros and the memory should be all 0, which means they would be deactivated. After that the decode will be enabled and the decode will count from 0 and 1 and 2 and then come back to 0 again. The memory will be starting after the decode stage has completed, and after memory has completed, fetch should start again and the counter should start from 0 to 14, that is hexadecimal 14 or decimal 20 again. So let's see the simulation. The timing diagram here will show the output, that the signal, how the signal pattern is generated. So as we can see, the clock signal started generating, and we have from 001 to 11010, which is the 10 value. Similarly, the D out starts right after that from 1 and 2, and after that we have the M out which starts from 0 and goes to 10. And as we can see from here, it has a clear signal pattern where the first fetch stage starts, and after that we have the decode stage, and after that we have the memory stage. So that's how we have designed. There is no overlapping between them. We have not made that. If you want, you can make an overlapping between them just by changing these marks options. So that's how we can design a sequential circuit where some part will be activated first and some other part will be activated later. I hope this will help you design your y86 processor and arrange the components in a sequential way. Thank you for watching.